So example 3, given f of x equals 2x squared plus 14x plus 20, answer the following. So we're asked to find the x-intercepts and the y-intercepts of the graph of this function. So again, to get the x-intercepts, we want points. We have the x-coordinate and the y-coordinate is 0. So we need to solve the equation 0. Our output is 0, and we want to know what inputs of x, what values of x will give us an output of 0. So we were given a hint to factor out a common factor first. So in here, each of these does have a common factor of 2. So we're going to factor that out. Give us x squared plus 7x plus 10. So if we think about redistributing, we get 2x squared plus 14x plus 20. Okay, so we've got equivalent expressions. We just have something now that's a little bit easier to factor inside. Coefficients are smaller to think about. So again, the first term is x squared, which we get with an x times an x. And to get the last term of 10, we'll try a positive 5 and a positive 2. And that will give us 5x plus 2x, which does give us our 7x for our middle term here. So again, we have the product of three things set equal to 0. Well, 2 can't be 0. Okay, so the 0 piece can't come from here. Okay, but either this factor or this factor then must be 0. So x plus 5 is 0, or x plus 2 is equal to 0. So this would say x is negative 5 or x is negative 2. Okay, so if we put the ordered pair together for the x-intercept, we get negative 5, 0, and an input of negative 2 gave us an output of 0. So the ordered pair would be negative 2, 0. And our y-intercept is a y-coordinate when x is 0. So we're going to put in an input of 0. So now we're going to solve for y when we have 2 times 0 squared is 14 times 0 plus 20. So we have 0 plus 0 plus 20, we get 20. So again, input of 0 gave us an output of 20. So together as an ordered pair, we have the point 0, 20. So now we're asked to compute f of negative 3.5. So we get 2 times negative 3.5 squared plus 14 times negative 3.5 plus 20. And so again, we can punch this like it looks here, keeping in mind this is a negative and not subtract. So make sure that you use, again, your button on your calculator that looks like this for negative. And if we compute f of negative 3.5, we get negative 4.5. So that tells us that for an input of negative 3.5, we get an output of negative 4.5. Okay, so this point is also on the graph. Okay, so now we have 5 different, I'm sorry, I can't count, 1, 2, 3, 4 ordered pairs that all make our equation true. And so we've got 4 points that must be on our graph. So now part C says to use the points from above along with the axis of symmetry to sketch the graph. Okay, so we've got a point at negative 5, 0, and another one at negative 2. Okay. So these points side by side, our axis of symmetry must come right down between them, okay, which is at 3.5. Okay, so our axis of symmetry is that x equals negative 3.5, okay, which is why I asked you to evaluate it, this function at that point. So at negative 3.5, we got an output of negative 4.5. So right here is negative 3.5 and negative 4.5. That point is on our axis of symmetry, so that point has to be our vertex. Okay. And then our y-intercept, okay, we got up at 20, okay, so he's like way up here somewhere. And we'd have somebody on the other side equidistant, okay, from our axis of symmetry here. And then again, if we kind of connect these with a smooth curve, it's kind of a skinny curve here. And we get our graph. So again, kind of missed my mark here, but we've got our parabola shape here with, again, we had 4 points that we had from up above, and then again, using that axis of symmetry, we can get that 5th point. Alright, so example 4, we're given a function and we're asked to find which values of x will give us a 6. Okay, so we're wanting to know, again on the graph, what inputs will give us an output of 6. So we need to solve. Okay, so we want to know where that output is equal to 6, so we want to solve this equation. Well, we should first note that this is not 0, so we can't use the zero factor property just yet. So the first thing we're going to do is we're going to make that 0 by subtracting 6 from both sides. So we're going to get 0 equals 2x squared plus 9x minus 11. Okay. Alright, so now thinking about how this factors, again, you can use other methods if you remember them, but again, I'm just going to use the trial and error method that we learned here. So to get a 2x squared for our first term, we get that with a 2x times x, and here to get a negative 11, try a positive 11 times a negative 1. So this gives us a positive 11x and a negative 2x, and when we combine like terms, we do get 2x squared plus 9x minus 11, which does match the expression that we need to get factored. Okay, so this factors as 2x plus 11 times x minus 1. So again, we have two quantities being multiplied whose product is 0. Okay, one of these two quantities has to be 0, at least one of them. So 2x plus 11 is equal to 0, or x minus 1 has to be equal to 0. So if we subtract 11 from both sides, we'll get 2x equals negative 11. Divide by 2, get x equals negative 11 halves. And over here, if we add 1 to both sides, we get x equals 1. So we were asked in this case to find the values of x that when we input them, the output is 6. Okay, so this tells us that if we input negative 11 halves, the output was 6. And here, when we input 1, the output was 6. So these points are on the graph. Now to answer the question that they want answered, just the values of x, they would be negative 11 halves and 1. No parentheses around here because this is not an ordered pair, it's just a listing of all possible values of x that would work. But we should think back to what that means on the graph as well. So an input of negative 11 halves gives us an output of 6, so that's an ordered pair on the graph. An input of 1 gives us an output of 6, so this is an ordered pair on our graph.